Hello students, welcome to video lesson 11.2. Today we're going to continue our discussion on multiplying and dividing rational expressions. So in our last video we talked about simplifying rational expressions. Remember, some polynomial or some group of terms over some other group of terms, right? Looking like algebra fractions, sort of. So today we're going to continue that discussion, and we're going to multiply and divide rational expressions, and then of course make sure our results are as simplified as they can be. Just like in our last video, our first step is going to be to factor everything that we possibly can, which means just separate it into pieces that are all multiplied together, right? So, for example, if we had something that we don't often think about as factoring, but if we have, let's say 3x squared y to the third, factoring that would mean basically recognizing this as 3 times x times y times another y. Okay, so we factor it out, we separate it into the pieces that it is multiplied, or that are multiplied together to make that expression. And most of that is going to look like factoring out a common factor from multiple terms. And we'll see examples of that. A lot of that is going to look like factoring quadratics as well, okay? So if we look at this first example of two rational expressions being multiplied together, as I mentioned, our first step is to factor everything that we possibly can. So I look at these four pieces now, the numerators and denominators of each of these two expressions, and I decide which of these can I factor. Well, x plus 3 cannot be factored because it's not a quadratic expression, and there's no common factor for an x and a 3. So that's just going to stay the way it is. The denominator of this can be factored. It is a quadratic expression. So the first thing that I'm always going to look for is, are there two numbers that multiply to make 35 and add up to be 12? That's not a very good plus sign. Add up to be 12. Multiply to make 35, add up to be 12. The answer is yes, I can do that. Those two numbers are a 7 and a 5, both positive. So I get this. So I factor that denominator there. And then I look at this other rational expression, and the top of it says x squared minus 25. That is a quadratic that is missing the x term. But this is one that way back in chapter 8, we recognized this as the difference of two things that are squared, right? X squared and then 25 is really 5 squared. So we can factor this then into x plus 5 and x minus 5. Okay, and then the denominator here, x squared minus 2x minus 15, is another one where I'm going to try to factor, because I see an x term in the middle, I'm going to try to find two things that multiply to make negative 15 and add together to make negative 2. So x squared minus 2x minus 15 can be factored because two numbers that multiply to negative 15 and add up to negative 2 would be a minus 5 and a positive 3. Okay, minus 5 and a positive 3. All right, so now I have everything factored. So this quadratic is no longer here. It's now these two factors. This quadratic is no longer here. It's now these two factors. This quadratic is no longer here. It's now these two factors. So really what I have is I have x plus 3 over, in parentheses, x plus 7 times x plus 5 being multiplied by x plus 5 times x minus 5 over x minus 5 times x plus 3. Okay, and once I have everything factored like this, we're now going to cancel any common factors, okay, entire common factors, things multiplied together, not just added or subtracted. We're going to cancel all the common factors that we can from the numerators and the denominators. Now, it can be anything in the numerator with anything in the denominator. It doesn't matter which fraction it's in, okay? Anything from either of the numerators with anything from either of the denominators. So what I want you to notice here is I have, I think, 3 things that can cancel out, I believe. I believe this x plus 3 can cancel with this x plus 3. I believe this x plus 5 can cancel with this x plus 5. And I believe that this x minus 5 can cancel with this x minus 5. Okay? So those are the things I can cancel out. There's nothing left on the top, actually, so there's obviously no more factoring that I can do. Okay? But when I'm done canceling everything out, we're then going to write the remaining factors all together as one fraction with no more multiply sign. Okay? So in this case, because there is nothing left in the numerator, okay, when everything cancels out, we are going to assume that there's a 1 left over. Okay, it's sort of like dividing something by itself, you end up with 1, right? It doesn't just go away and become 0, it becomes 1. And then the denominator, the only piece left with this one gone, this one gone, this one gone, is this piece. So the denominator says x plus 7. Okay? Now, if there were multiple pieces left over, you can leave them in their factored form, okay, in their parentheses next to each other. You don't have to FOIL them out again. But this is the final simplified version. 1 over x plus 7 is what I get when I multiply these original sort of crazy looking rational expressions. Okay, so for multiplying, step number 1 is factor. Step number 2 is cancel. Step number 3, write all together. Okay, so that's multiplying. When we move to dividing, a lot of things are the same, but there's one key important difference that we'll have to take note of here in just a second, okay? So when we're dividing two rational expressions, the first step is the same. I always want to factor everything that I possibly can first. Okay, so it's the same first step. Give myself a little bit more room here. And I'm going to look at all of these pieces and I'm going to try to decide if they can be factored. And if so, how I can factor them, okay? The first thing that I see on the top of the left-hand expression is b squared plus 4b plus 4. That's one where I just see a b squared, so I'm looking, I do see a b term in the middle as well. So I'm looking for two numbers that multiply to 4 and add up to 4. Two numbers that multiply to 4 and add up to 4. Well, that would be, I shouldn't use x though, because this is b's. B plus 2 and another b plus 2, because 2 times 2 is 4 and 2 plus 2 is 4. Then on the bottom here, I see 2b squared minus 8. So again, the first thing that I'm always looking for, remember, is a common factor between the two pieces, something that I can divide both of them by. In this case, I want you to notice there's a 2 here and an 8 here. 2 and 8 can both be divided by 2, so I'm going to do that, okay? And then 2, if I factor it out of this, becomes b squared minus 4, okay? Now, I'm not quite done factoring because what's left in the parentheses there is, again, the difference of 2 squares. So this is b squared, and 4 is really 2 squared, so it can be factored into b plus 2 and b minus 2. Okay, so really what I have on the bottom is this, 2 times b plus 2 times b minus 2. Now, in the right-hand expression, the numerator is just one thing. Okay, it's a monomial. It's not added or subtracted to anything. So we're just sort of recognizing this as 4 being multiplied by b. Okay, and then in the denominator, I have 3b minus 6. That's not a quadratic, but I do see a common factor for these two pieces. 3b and a 6 can both be divided by 3, so I'll factor this out, 3 and then b minus 2. Okay, so now that I have all these pieces factored as much as I possibly can, I'm going to do my one extra step for dividing. Okay, and that is when we are dividing rational expressions, we really want them in the end to be multiplying. Okay, because when we're multiplying, we can cancel things from either numerator and either denominator. So in order to change this division sign or this division problem into a multiplication problem, I'm going to flip the second fraction over, meaning find the reciprocal. So instead of having 4 times b over 3 parentheses b minus 2, I'm going to flip these two things around, okay? So the right-hand side is going to become 3 parentheses b minus 2 over 4 times b. Okay, and now like I said, by flipping that over, I'm now allowed to change the division sign to be a multiply sign. So instead of division, now it says multiplication. Okay, and that's the key for me to cancel in just a second. And then I'm going to write what's left over here as well. So the numerator on this one is not going to change, right? I'm not flipping the first fraction. It's just the second expression that I flip over. So the numerator is b plus 2, and the denominator is this 2 times parentheses b plus 2 times b minus 2. Okay? So now everything is factored, and I flip that second fraction so it's now multiplying. That allows me to now cancel everything that I can. Okay, so I'm going to take any piece that I see here being multiplied, not added. Okay, so just so we're clear, I do not get to cancel this plus 2 with this 2 right here. Can't do that because this one's added on to a b. So if it's added on to anything, you can't cancel it. But when it's just multiplied, particularly in parentheses, you can always cancel those things, okay? So the things that I notice here that can be canceled, I see a b plus 2 and a b plus 2. I see a b minus 2 and a b minus 2. I think those are the only two things that can be canceled out. So I do that canceling, I eliminate those, and now what I'm going to do is I'm going to write the rest, whatever's left over, as one single fraction, okay? So if I take what's left in the numerators, I see a b plus 2 in parentheses, and I see a 3. Okay, so I do that. Now, generally, we write numbers before anything with variables. So if you want to write 3 times parentheses b plus 2, that's okay. That's the same thing. That's probably how you would see it in an answer key. And then the denominator on the left is just a 2, and then it's multiplied by 4 times b. Okay, now I can do a little bit more simplifying here. 2 times 4 is 8. So I can make the bottom just 8 times b, or just 8b. And I'm going to move that down so that I have a little bit of room here. And then the numerator is still b plus 2 in parentheses times 3. Now there's nothing else that can be canceled here because 3 does not cancel with 8, right? There's no common factors there. And this b plus 2, I don't see a b plus 2 on the bottom. I see a b, but I do not get to cancel this b with this b because this b on the numerator is plus by 2, okay? So they cannot cancel out. So this is my simplified version. Now, the back of your book will probably distribute the 3. You're welcome to do that as well if you'd like to. Become 3b plus 6 over 8b. Okay, that maybe is the simplest way to write this, but I'm not going to make you do that, okay? If we have everything factored out, then we can see if there's anything else that can cancel. So I maybe prefer this version, but if you want to multiply it back together, that's totally fine, okay? If you have any questions about the steps to either multiply or divide rational expressions and make sure their answers are as simple as possible, do please reach out to me. Let me know. I'd be happy to help. I'm available on Zoom, or send me an email, or give me a call. Otherwise, that's all I have for you right now, and we'll talk to you soon.